Okay, all right. So here's what we're gonna do today. Since for a little while we were graphing a lot with quadratic functions, today we're gonna talk about transformations, which is not new from for our sake, right? Because we're just talking about what are the things we could do to the quadratic function that will make it move around. Okay, so all right, let's go. Okay, all right. So today what we're going to talk about is transformation with the parabola, right? Meaning with the quadratic functions. So let's take a look, okay? Now, with transformations, again, right, there are different kinds of transformations, right? Because we can have reflection, rotation, dilation, and translation. So what I'm really more specifically talking about here is not any other kind of transformation. We're really specifically talking about translation. Okay? Meaning, like, can you just move a graph around, and what would it take for you to be able to move a graph around? Like, what sort of changes would you have to make toward the quadratic function equation itself for the graph to look different? Now, it's going to be very, very intensive with the graphing calculator. So again, have your graphing calculator out, and we'll go ahead and try some of these. Now, right off the bat, right, let's talk again about what a parent function is. So a parent function, right, for a parabola, for a quadratic function, is like this, right? It's like y equals x squared, right? That's not a y equals x squared, right? That's the basic parent function, right? So in other words, like, if one of the things I want to get through in this lesson is, like, if we make the smallest of adjustments, what would it do to the curve? And not only that, we can isolate each of the things, okay? And you see what I mean in a second. So, okay, actually, you know what? Let me give you an overview. So the first thing I want to talk about is, so if this were a parent function, and this is like a very, very, generic version, right? I mean, it can't get any more generic than this, right? Because I'm not even using numbers. I'm using letters in place of the numbers, right? With A, B, and C. So the question is something like this. If I change A and A only, what would happen? If I change C and C only, what would happen? Okay, so that's what we're trying to accomplish today, all right, and learn. So, okay, that's it, all right. Let's take a look at the first one, right? So we got y equals x squared. So what I'm going to do is go to y equals x squared and graph that, right? So you got your standard graph, right? Now, what I'm going to do is I'm going to graph the next graph on top of this original graph, just so that you can see the sort of transformation that's happened, okay? Now, here, instead of just x squared like I had it, I'm going to change it to 4x squared. So I'm going to take the x squared, whatever that is, and multiply it by 4. So let's see what happens, all right? So here in the second line, I'm going to write in 4x squared, graph that. Now, have you noticed, right? The red is the second one, right? That's 4x squared. What have you noticed about the graph, the U shape? Yeah, it's more narrow, right? So, okay, now, let's see, what's the best way to go about this? Actually, you know what? Let me take a snapshot of this, okay? And then what I'm going to do is I'm going to paste it just so that, you can get to see everything at once. All right? So let's see. Let me make that really small, like that. All right, that should suffice, right? Yeah, okay. All right, now, secondly, I'm going to erase the red one, and I'm going to change it to 1/4 x squared. All right, so let's go back here, and you're more than welcome to follow me. All right, I'm going to erase this one, and I'm going to change it, 1/4 x squared. Now I'm going to put a parentheses around the quarter, just to make sure. All right, close, and then x squared, like that, right, 1/4 x squared, and now I'm going to graph it. Look at this red line, right? So it's a lot wider, right? So let me take another picture of that. Now notice the whole time the blue line hasn't changed yet, right? Because that's the original function, right? So, and we're doing that on purpose here. Okay, like that. And then lastly, I'm gonna go, now, that's the regular x squared. So I'm just gonna, probably didn't need to do that, and I'm not gonna do that now, okay? Because it's both blue lines here. Now, right? So the question is something like this, right? And these are the notes that you should probably take, all right? Changing the leading coefficient, right? The leading coefficient of a quadratic function will what? All right, okay? So this is how it goes, right? So if the number is greater than 1, if a is greater than 1, the graph, right? If it's greater than 1, the graph actually narrows. Graph narrows, right? If a is less than 1, meaning like something like this, right? Because this is the original, right? This is 1, right? So anything greater than 1, graph narrows like this in the red. I should have used red. It might be easier to match that way, but that's all right. If it's less than 1, meaning a fraction, right? As it gets smaller and smaller, right? The graph widens. Okay, so in other words, the greater this number, the wider and wider it gets, the smaller and smaller this number becomes, all right? It starts to widen. Now, some of you might say this, Mr. Ring, isn't that counterintuitive? Because like, if the number's bigger, shouldn't the graph go wider? And that's not a bad first impression to get about the graph, but the way I would like you to remember is, think about it like this, right? The higher the value of the leading coefficient, the a value, right? The higher the a value, think of it like this, the more you want the graph to change, okay? It's like you want more evolution or revolution, you know, like meaning spinning, like a car. I'm using a car reference, right? Like, so the higher the a value, the more changes are taking place. So the more changes are taking place, the narrower the graph becomes. All right, it's more like dramatic. Think of it like that. All right. Whereas the slower the number is, the lower the number is, it makes the graph wider and wider. So I bet if you change this to 1/8 or 1/16, the graph is going to be practically flat. Okay, not a good drawing, of course. All right, the graph is going to be practically flat. It's basically saying, hey, minimize the number of changes that you need. That's why these numbers are so low. So that's one way you could think about it. All right, now let's see how the time is. Okay, all right, now, so let's see what happens then, right? The second thing we need to see is we're still looking at the a value here, right? We're still looking at the a value. That hasn't changed yet, okay? So we want to see, okay, what happens, what's the difference between a positive leading coefficient and a negative leading coefficient, all right? So that's the second thing we need to look at. So let's take a look at it. Now, I'm going to keep the first one, clear the second one, but I'm going to make this one negative, all right? So negative x squared, grab that. Ah, what's happening? Yeah, flips upside down. So when the leading coefficient is positive, right, parabola faces up, right? When it's negative, what happens to parabola? Yeah, it faces down. Okay? All right, let's move on. Now, these are, now I want to know, what if I add a number toward the end, meaning the constant? So for example, in this case, -4, right? So this is the original, right? Again, this is the parent function, right? The parent function. This is the kind of a parent function, right? It's just the 2 here, okay? And here, the only thing different between, so for example, let me highlight it for you. The only difference between a and b here is the -4, right? The only thing between 2x squared and the second one here is the +3 here, okay? So now let's graph it and see what that looks like. So, all right, let's go back to the calculator. So I got x squared, so now I'm going to do x squared -4. So I'm going to delete the second one. What was it? X squared -4, right? Because I just literally just said it like that, right? Yep, okay. Graph that. Aha, have you noticed something? What happens when you do -4? Yeah, the graph shifts down, okay? So let me take a picture of that for you guys. So we got this going on. picture here like this. Okay, right? The blue is the parent function, right? And then now let's take a look at the other one, 2x squared. So now I'm going to change both of them. So that's 2x squared. Clear. And now I'm going to do 2x squared plus 3. Yeah, yeah, okay. So let's graph those. That's the first one. The second one, plus 3, right? It shifts up. Have you noticed? All right, let's take another picture of this. Oh, the lights are off. Hold on. All right. So now, what happens, right? When a constant is added or subtracted, if you add it, so let's see, hold on. Add, the graph goes up, right? If you subtract with a constant, the graph, right, shifts down, okay, as you can see, right? So that's it, right? And by the way, so for the first one, if you minus 4, it'll go down 4 units. 1, 2, 3, 4, right? And on the other hand, with the second one, it'll go up 3, right? 1, 2, 3, like so, okay? All right. Now, how are we doing here? Okay, so to summarize real quick, all right? And this, I'm gonna tell you now, this video has to be 20 minutes long because I have to narrow down, the amount of days that we spend in this unit, all right? In light of the regions in June, okay? So now, hold on. So to summarize, right? And you should really write this down, all right? You really should write this down, all right? So when we're focusing on A, the leading coefficient, right? It either goes narrow or wide depending on the value of the number, right? So if it's 1, nothing happens. If it's a fraction, it gets wider and wider. If it's more than 1, it gets narrower and narrower, right? If the number is positive, the parabola phases up. If it's negative coefficient, right, the parabola faces down. And lastly, the C here tells you whether the graph is gonna shift up or down, okay? So it's just one thing here, okay? Got that? All right, now, let's go to vertex form, okay? So in the vertex form, all right, and this, I can already tell this is more about, you know, giving you the notes rather than actually giving you questions to practice on, all right? We'll do the regions questions tomorrow. Now, if I give this to you in the vertex form like this, right, it really hasn't changed that much. I don't know if you realize this because we've talked about this vertex form as far as HK is concerned, where H and K is the vertex, right? That's something we probably talked about 2 weeks ago at most. All right, so now I already did the experiment for you guys. All right, so the first one is x squared. So I'm gonna write the formula next to it, okay? So this is x squared. And for this one is x minus 2 squared, meaning, by the way, I'm keeping the vertex form, by the way, all right? So I'm gonna keep that up there, right? Y equal to, let's see, x minus 2 squared. Now, here I didn't add the k, right? That means that's a 0, right? I mean, you know, maybe I should write plus 0, okay? Just to kind of emphasize the point, and I'll do the same with the first one. Okay, again, I'm only writing the plus 0, all right, to emphasize that the k right now is 0, okay, just so that you could see a little more obviously, all right, okay, so let's see the last one, x plus 2 squared plus 0, like that, okay, that's all. I just want you to notice the difference. Now, if that's the case, let me bring this guy down. If that's the case, let's compare then, right? So what happened at this one? Nothing happened, right? Let me use a different color. I'll use green. Stands out. All right. So in case number 1, right? Case number 1, right? X squared is just a parent function. So like every function looks like this. right? So now let's take a look at the next one then. Minus 2, have you noticed? We talked about this briefly, right? Remember, if we say minus 2, right, this is really, so we look at case, what am I doing? All right, if I'm looking at case 2, right, I'm really looking at x minus 2 equals 0, so x equals 2. So the vertex, the x coordinate of the vertex is 2. Meaning if you subtract 2, and we talked about this again already, x minus 2, which means the graph shifts to the right. Right, remember it's the opposite, all right? I already gave you the rationale for that, okay? So, right, the vertex goes to the right here, even though it says minus 2, right? Now, lastly, just to prove the point, in our third scenario, if this is plus 2, then the graph shifts left, okay? And moreover, not just the graph itself, it's actually the vertex also. So when I mean vertex in this case, I'm also making a point to let you see that, right? The graph is going left, right here, okay? So here it goes left, right? So in that case, right, something like x minus 2 equals 0, so x equals 2. Oh, this plus 2, oops, minus 2, that's why it's negative 2, right? So the x coordinate of the vertex is negative 2 right here, okay? All right, so far so good. I know I'm moving slightly fast, but there's no practice here. So if you want to, if you didn't understand this the first time, I would strongly suggest that you rewatch it, okay? Hold on. Yeah, we're doing all right. All right, now let's see. The vertex form, we talked about this already, all right? Where, what is the vertex? Which letter? I mean, look at this, all these letters. F, X, A, X, H, K, right? Which one's the vertex? Yeah, HK, right? If you can't remember that, just remember where Old Manning is from. Hong Kong, all right? So if that helps you memorize it, all right, and also remember where I'm from, then maybe that's a good thing, all right? Let me draw this arrow. Not sure why. All right, HK, Hong Kong, all right? So remember me that way, all right? Hong Kong. All right, okay. Moving on. What about changing the A, right? The leading coefficient in the equation in the vertex form, right? So hold on, let me try to like bring this guy down here, okay? So let's see, where can I put it? Maybe up here. Yeah, okay, all right. Right now, the A here slightly different than the A in the other one, right? Because this is the quadratic form, right? And this is the vertex form, right? Standard form versus vertex form, right? So how would that change? Well, I did it again already, all right? So now this is so let's assume, right, we're keeping all this part. We're keeping all this part here, all right? Just ignore the K for now, all right? Because we talked about that already. So for this one, right, so if I keep this and I change only the A, right, what would happen? So, okay, so this is like the what we start off with. That's the graph. Now let's see. If you add 5 here, look what happened. What happened to this graph here? Yeah, became more narrow. But isn't that true over here also? Like, wasn't that true, right? Narrow or wide? We talked about that already. So nothing changed there, okay? What else do I have to talk to you about? Oh, if you make a really, small number, like a fraction, look how wide or flat, actually. I think that might be a more useful word for you. The graph becomes more flat, okay? Nothing new here again. Now, let's see. All right, so again, to summarize today's lesson, all right, in 2 parts, okay? So the first things first then was this, right? Let me see, is there another color I can use? Okay, all right, oops, all right, purple, all right, right? So narrow or wide, right? So leading coefficient, narrow or wide, and if it's a positive value, the parabola face up. If it's a negative value, parabola face down, right? And with this one, the C here, right, the constant, right, it makes the graph go up or down. So if you add, it goes up. If you subtract, it goes down, right? And similarly, this one here, right? Again, doesn't really change anything. This one here, right? The leading coefficient tells you that whether the graph is narrow wide, right? So the higher the number, the narrower it is, right? And then positive, negative, same thing. This thing, the only thing that's different, I would say, between these two is this one, the vertex form addresses the vertex. I mean, right? Makes sense, right? And not only that, it makes the graph go left or right, right? As I've just demonstrated to you down over here, right? Goes right and then went left. And then for this one, the K, it shifts the graph up and down, just like C here. Just like C here, right? That's why I kept the same color. Have you noticed, right? So the constant goes up or down. In this case, it's not a constant, it's the K, okay? Because we're talking about vertex form here, right? So, okay, that's it, all right? HK tells you the vertex, and H tells you the axis symmetry. So it's a lot of information, but I think if you take a little bit of time to write down these two in particular, all right? This one here, if you write this down, and then you write this down, I think you guys are gonna be okay, all right? And, okay, yeah, it's 21. All right, gotta go, all right? Tomorrow we'll practice and do some regions.
Wait, hold on. We're not done yet, okay? We're not done yet, hold on.
Okay, all right. I just realized this. If I spend another 5 minutes on the regions questions, there's basically no need for another lesson the next day. So let's spend 5 minutes here so that we don't have to spend 15 to 20 minutes tomorrow. How about that? All right. I think that's a bargain. So what I'm going to do is I think I'm going to go over 3 to 4 questions with you. Let you try the rest on your own. All right. Especially if you're inclined to take the regions, really, because I only picked out the multiple choice questions, and then afterwards I can show you the answer key. So a lot of this part now is kind of a self-motivating exercise, all right? So let's try at least a couple, okay? All right, so number 1, it says, given the graph of a line represented by this equation, so let me highlight that. All right, so that's the equation, wrong color. I'm gonna switch the color, it's too bright. All right, here, if B is increased by 4 units, right? So this is increased by 4 units. Okay, so let's see. So I'm going to rewrite that. Right, so if B, so f of x is negative 2x plus 4, right? So we're adding 4 to it. The graph new line would be shifted 4 units. What do you think? What do you think when you add a number like that down here in the back like that? Yeah, it shifts up, right? Okay, all right, moving on. All right, then there's my answer key. All right, okay, all right. Number 2, what is it now? Number 2, the functions of the graph. Yeah, let's see, so this is the function. Highlight that. All right, and graph it below. So I got, now, I want you to read this. This is kind of tough to read, okay? Because I'm trying to picture back when I was in high school, and I don't recall doing this sort of operation until I was like probably well into high school, okay? Maybe a junior already. So what this is saying is this, okay? Don't get too confused here. So we got 2 functions here. We got f of x, right? Which is this good old quadratic function here. And then we got g of x. Now, have you noticed g of x is f of x plus a number? All that means is this whole thing plus 9 plus another number. So I'm going to color code it, okay? I'll use red. Plus another number. That's the change, all right? So notice how these two are the same, just adding k to it, okay? That's all that means. So don't get too intimidated by that, all right? So we got that. Now, what's the question? Okay, so now I got to examine the graph, right? I got f of x here. Now I got to do a better job labeling this. I don't think it's written big enough. So now notice, right, how we went from f of x to g of x, right? So notice how the graph went down, right? That's the transformation, right? We got f of x. g of x went down. Now think about that. What kind of number does this have to be for the whole graph to shift down? Yeah, first of all, it has to be a negative number, right? And how many units is it? Let's see, 1, 2, right? So it went down 2. So that's 4, okay? All right. Now let's see. Hold on. All right, for number 5, what does it say? Let's see, the graph. So again, like fairly generic looking equation, all right? So, right, as you can see. Now, here it got a little addition here. We got the a, so keep an eye on that, right? Now, if a is multiplied by negative 1/2, meaning really, imagine it like this, right? Instead of where a is, I put the negative 1/2 x squared, right? So there's your leading coefficient, right? Remember that, right? So if it's multiplied by negative 1/2, now, first of all, what's gonna happen with the negative sign? Yeah, the graph is gonna flip upside down, right? It's gonna face down. And then what happens then? The half, what is the half gonna do? Is it make it wider or more narrow? Think about it. Remember what I said, right? Half makes it more wider, right? Makes it wider, not more wider. So it looks something like that, okay? Again, not a great drawing, but all right, let's see which one is true. So it wider downward, right? Wider downward. Wider opens downward. That's it, okay? See, it's not so bad, right? It's doable, okay? Hold on, let me just, okay, you know what? We've reached 5 minutes, and I don't want to, well, at least the part where I'm talking, I don't want to go over 5 minutes. So here's what we've done so far. We did 3, 1, 2, and 5, okay, alongside with the answer key. So right now, here's what you should do. Try 7, 8, and 9, okay, because these are all multiple choice. So do me a favor, try 7, 8, and 9. Again, really do go forward with this if you think you will take the regions, especially because you will need more practice, okay? So try 7, 8, and 9, press pause right now, and I'm gonna show you the rest of the questions, and I'm gonna show you the whole answer key at once, okay? All right, so press pause right now. Okay, so now I'm gonna shift down, all right? Let's see, 10, 11, 16, yep, all right? So try those 3 right now, so press pause right now. All right, now let's try 17 and 21. Now 21, I know what it looks like, but I'm giving it to you on purpose also, because I still want you to try it, okay? It's because if you get it right, it's gonna confirm everything you know, all right? So press pause right now. Okay, so here's what I'm gonna do right now. I'm gonna show you the answer key, okay? And so you can check your answers that way. Now, what on earth is happening here? All right, okay, here we go. All right, this is the answer key. Okay, so again, if you want to, press pause right now to check your answers. Otherwise, I'm gonna sign off here, okay? So thanks for hanging in there. I know this is a long video, but I thought by saving a little bit of time, saving a lot of time tomorrow, it's gonna help us finish the curriculum, okay, before the regions. Okay, all right, thanks for watching, bye-bye.
OMG, that was so good.